All right, so it should look like that, right? I'll give you a couple seconds to get there. While I get there on my other side here. Okay, so we're going to talk about two different types of angles and a way to apply our right triangle trigonometry to a real life scenario. Okay, so we're going to do the angle of elevation and the angle of depression. Okay, so the angle of elevation, you guys probably already know this, but let's see. When you push the button on the elevator and get in the elevator, which direction are you typically going? Up. So its angle of elevation is an up, okay, angle. So officially, that would be the angle going up from a horizontal line. And the horizontal line piece is important, okay? So the angle going up from a horizontal. So if I look at this picture, I've got this horizontal line here, the one going up to that diagonal, okay, or that transversal, okay, is the angle of elevation, okay? All right, when we are depressed, we say that we are what? Down, right? We're feeling down. So the angle of depression is the down angle. It's the angle going down from a horizontal line. And again, that's really important. This is the one people usually mess up, okay? Okay, so here is my horizontal here. The angle of depression is this one here, okay, to that diagonal. Do you see how there's another angle sitting right in here? That is not the angle of depression because that's not the one coming down from the horizontal. So it's kind of like there's an invisible angle. You draw the wall out from the building, and that creates the angle with the right triangle there. From geometry last year, okay, or this year, so for some of you, those actually, what do we know about those two angles?
They're on the y-axis?
Not on the y-axis.
What angles are
This one?
They're equal.
They're equal, right? Does anybody remember why?
Because
They've got a special name. They're alternate interior angles, and that means that they are congruent to one another. So this one is congruent to that one, or they're equal to one another. So the thing is that if I get the angle of depression and my triangle is down low, I just pop that angle down in the angle of elevation and I've got my angle for my triangle, okay? So they are one and the same. Whichever one they give you, they're the same thing, okay? All right, let's take a look. The best part about this is you get to see my fabulous drawing skills. The first 2 years I was here at Talkwitz, they actually let me teach multimedia, which is technically an art class. You're going to see why they let me teach it for 2 years here in just a minute. All right, so we've got a parasailer is attached to a boat with a rope 300 feet long. The angle of elevation from the boat to the parasailer is 48 degrees. Estimate the parasailer's height above the boat. All right, you ready for my fantastic art skills? Okay, here we go. So we've got we got to have some water if we're gonna have a boat, right? So we got some water. Let's get some water. Okay. Then we need to draw a boat. Here comes my boat. Best boat ever. Because this would be the type of boat we would use for parasailing, right? All right. And then we need a parasailer, okay, attached to a rope. So now to make the math easier, we're going to pretend that the parasailer is attached to the bottom of the boat because it just makes the math a lot easier. Okay. All right. Here's the parasailer up here. And there's his, like, parasail thing. There we go. Can you believe they let me teach an art class? Isn't that amazing? All right. And then, so it says that I always label my picture. The rope is 300 feet long. So this is 300 feet. Okay. The angle of elevation from the boat to the parasailer. So from boat to parasailer. So this is the horizontal on the wavy line, right? And then to the parasailer is 48 degrees. Okay. And then I would create the rest of my right triangle. So the goal is to try to create the right triangle. Estimate the parasailer's height above the boat. It probably should say above the water. This is what we're really looking for right here. Okay. So I need to identify what parts of the triangle that I have. Okay, in order to determine if I need to use sine, cosine, tangent. I could use cosecant, secant, cosecant if I really wanted, or cotangent if I really want to, but it doesn't matter. Okay. All right, so what is the x on what part of the triangle? Opposite, good. And then what part of the triangle is the 300 on? Hypotenuse. So if I have opposite and hypotenuse, which trig ratio do I have? Sine, good. So we're going to do sine of how many degrees? 48 equals opposite x over 300 hypotenuse. Is that any different than what we did last week? No, it's the same exact thing, except I had to draw my own picture and interpret my own picture. That's the hard part, okay? All right, how do I move the 300 to the other side? Multiply, so you've got 300 times the sine of 48 equals x. All right, we learned on Friday during our quiz that we have to be really careful on our calculators, right? And make sure we're in the right mode. So if you go to Google Classroom and you scroll all the way down, I think I showed this to you last week, but in our Google Classroom, or if you instead of alt, you grab, maybe did I put it under resources? I don't know if it went to the top. No, it went here. It's under week 4. I'll move it to, maybe I might move it down, but if you grab this one and you grab that graphing calculator, it defaults to degree mode. Okay, so. And we will make sure the next time we do this, if I don't use the graphing calculator, if I use the whatchamacallit one, the scientific, that we remind ourselves how that mode is supposed to look. I put a little screen, a slide up for 5th period since you guys had so much trouble. All right, so we had to do 300 times sine of 48. How many decimal places do I make you keep? 3. So 222.943 feet. Okay, so let's write that down. So 222.943 feet. Okay. All right, we're going to try one more. Okay. Any questions on how to do angle of elevation? All right. Number 2, a boat is in the water, so we get to draw another boat. Fantastic. Okay, I'm good at drawing boats. All right, the water level is 20 yards below a cliff. If the angle of depression from the cliff to the boat is 37 degrees, how far is the boat from the cliff? Okay, so we need some water. Water. We need a boat. Boat. Okay. I probably drew my boat way too big. We need a cliff. Here's the cliff. Okay. All right. We need the angle of depression. So remember, angle of depression has to come down from a horizontal. So from the cliff to the boat. Again, put the angle at the bottom of the boat so it makes the triangle make a little bit more sense and easier. So if this angle here is 37 degrees, by alternate interior angles, I also know that this angle is 37 degrees. Okay, we got to also label some other things. So it looks like the water level is 20 yards below the cliff, so this is 20 yards. It wants to know how far is the boat from the cliff, so they're wanting this value right here. So we got to figure out what parts of the triangle we actually have in order to solve for x. Okay, so what is the 20 on what part of the triangle? Opposite, good. And what is the x on? Adjacent, good. And when I have opposite and adjacent, what trig ratio is that? Oh, I wrote that wrong. Opposite and adjacent, what trig ratio? Tangent, okay, so tangent of what? 37 equals what over what? 20 over x, and then I gotta, how do I move the x to the other side? Multiply, so x times tangent of 37 equals 20, and then how do I move the tangent of 37? Divide, good. All right, so we're gonna all go back to Desmos again, okay? Let's divide this out. All right, so we've got the 20 divided by tangent of 37. How many decimal places are we keeping? 3. Okay, so 25.54 what? Do I keep it or do I round up? We got to round up because it's an 8, right? So 541. All right, so 20x equals 26.541 yards. That's a terrible looking Y. Yards. All right. That is it on that piece. Okay, any questions